This video is going to show you the size of things, comparing microscopic things to each other and also to various measurements you might know. So for instance, here we have a pin being held in a hand, and here's the units in this picture. So 20 millimeters equals this length of this green line. So you can imagine you can't actually move it in this animation, but if I were to imagine this length, I'm going to kind of approximately draw it. It might start right here on the pin, and it might go out that far. So that gives you an idea that a pin is less than 20 millimeters, or probably about 2 millimeters wide. If I look at this line again, I can see that the thumb is about 20 millimeters wide, and the pin, the length or the width of the pin is a small fraction of that, estimating probably about 2 millimeters. So as I move along and I magnify, different things are going to come into view. Okay, so I get a little close up of that pin at, and then a further close up, and finally I'm starting to see a hair here, and it's kind of telling me down here, how many, the magnification that I'm using. So what's really interesting though, as you at 10 times magnification, right? Now all of a sudden I'm not at 20 millimeters, but I'm now more focused in, so I see less. But now so we have a unit of 2 millimeters, so we can measure these smaller, these magnified images. So what was once 20 millimeters in regular view, right? If we magnify that by 10, I have to divide that by 10 to get my new unit. So 20 divided by 10 is 2 millimeters. And so this pinhead is approximately that length, 2 millimeters. And the interesting thing on here is we could start to see some other things come into view, like I'm not sure what this is. So if I click on these different things, I could realize that that's, or it'll just show me the different things that are beyond here. So let's go back down that magnification, back to where we were. But I realized that that is a hair, and those other things are the dust mites that we're seeing. So we're back at 2 millimeters. Again, that's probably the length of the pinhead. And so I can see how much smaller this little speck, which I know now is a dust mite, and compared to the hair, how it's much smaller than that. So again, it's very hard to understand how small things are in the microscopic world. And I think this presentation does a really nice job of at least showing you approximately how big things are comparatively to one another. So let's magnify some more. And we're getting a nice view of this this dust mite and this hair. Here's another dust mite there. And there's something else coming into view that we're not sure what that is, but we know that it's much smaller than a dust mite. And now our line is, as we go to 100 times magnification, well, now we have to divide that by what we're looking at, and we get to 200 micrometers. So now this length represents 200 micrometers. And so to understand what a micrometer is, okay, micrometer is 1 to the negative 6, or 10 to the negative 6. So, or another way to say it is that a micrometer is, I think it's here, micrometer is 1/1,000,000th of a meter. So now we're not quite at 1/1,000,000th, but we're at 200 millionth. So 10 to the negative 6 is the picture that we're looking at right now. And 200 of those. So these are really, really small, right? Going back 6 places to the right, and we have 200 of those. So it's a really small number. Okay, so let's magnify some more, and we start to see some other things. We're not sure what they are, but these are now 20 micrometers. So we're at 1,000 times magnification, and we divide that by what we had, by what we had originally, and we're another magnitude of 10 less than that. So where we had 200 micrometers, now these things are only 20 micrometers. And this one is ragweed. This one's a lymphocyte. These are red blood cells. This is baker's yeast. And we see some smaller things coming into view there, but we'll get back to those. I want to go back and talk about these yeast. So whereas we have the ragweed pollen is 20 micrometers wide, right? Much smaller than, or 10 times smaller than what the dust mite was. And these other things are even smaller than that. Okay. Magnifying further, we get into 2 micrometers, so another magnitude of 10 less. And again, a micrometer is 1/1,000,000th of a meter. So, you're looking at, maybe I got to focus in a little more. Let's see. E. coli, Staphylococcus, these are types of bacteria. So these are how big small bacteria is. And this is the Ebola, and that just magnified again. So I'm going to go back for a minute. That's the Ebola virus you hear about. Okay. So again, these are 2 micrometers. So when I look at 2 micrometers, about the length of 1 E. coli, and each of these Staphylococcus bacteria cells are probably half that, right? Probably about 1 micrometer in diameter, if I had to estimate that. Okay, whereas the red blood cells are, at least I'd say 20 micrometers long, right? Much, much larger than what these things are. And let's magnify further. And we start to get, now we get into nanometers, right? Another unit. And a nanometer is a billionth of a meter. So, sorry about that. A nanometer is a billionth of a meter. Okay? And so it's, sorry, my menu bar is in the way there. But anyway, that shows 10 to the negative 9 down here, which is the same thing as you're seeing on this slide here, a billionth of a meter, right? So we know what a meter stick looks like. This is 1/100000th of that. And it is 3 more places or 6 more places to the right of a millimeter. So imagine breaking up a millimeter into 100,000 parts. Okay, and that's pretty much what you're looking at with a nanometer. All right, so really, really tiny stuff, these viruses. And there's something else that's even smaller. So this is 200 nanometers, and now we're going to go even smaller than that. And we get to the rhinovirus, which is only 20 nanometers in width. As you can see here, this line is about the length of that. And so some viruses are extremely, extremely tiny, tiny, tiny. So just to give you relative sizes and understanding of how this animation worked, and to give you a better understanding of how things are in relation to one another in the microscopic world.